Alrighty, let's take a look at this problem from section 4.5, problem number 7. And we're going to solve the system of linear inequalities. So first of all, we're going to take this 3x plus y less than or equal to 2, and we'll write the related equation, which would be that. And then we'll find two ordered pairs that are solutions. So I'm going to find the x-intercept and the y-intercept. To find the x-intercept, set y equal to 0. We get 3x plus 0 equals 2, or 3x equals 2, or x equals 2/3. To find the y-intercept, we set x equal to 0, and we get 3 times 0 plus y equals 2, so y equals 2. So now we've got two ordered pairs that we can use to graph the linear inequality. So here, okay, now when I go to graph 2/3 0, it's going to jump over to 1, but don't panic, we'll come back. 0, 2 is right there. So my first point should be 2/3 0. So 2/3 0, and my second point 0, 2. Now, looking at the original inequality, we see that it includes equals, therefore the line should be solid. I need to pick a test point to figure out which side of the line to fill or to shade, whether to shade this side or that side, okay? So now let's pick, how about 0, 0? That's a good test point. It's not on the line. So 0, 0, and I'm going to put that into the original inequality. So I'm going to have 3 times 0 plus 0 less than or equal to 2. 0 is less than or equal to 2. That's true. 0, 0 is below, so we're gonna go below. So for this first one, we would fill it on that side of the line, below the line. Okay. Now let's go back and do the red inequality. I'm going to look at the related equation. And again, I'm going to find a couple of points. Again, I'll go after the x and y-intercepts, I think. To find the x-intercept, set y equal to 0. 4x minus 0 equals -2. 4x equals -2. Divide both sides by 4. Reduce. X equals -1/2. And then if x equals 0, 4 times 0 minus y equals -2. Negative y equals -2. Divide both sides by -1. Y equals 2. So now I've got two ordered pairs there. -1/2, 0, and 0, 2. Now, -1/2. So I'm going to make that -1/2, 0, and 0, 2. This inequality also includes equals, so it also would be a solid line. And again, I can use 0, 0 as a test point. Okay. So 0, 0, plugging that into the original inequality. 4 times 0 minus 0 greater than or equal to -2. 0 is greater than or equal to -2, so that's true. And that second line, which is over here, 0, 0, it's below it. Okay. So let's go back. This first inequality, the black inequality, would be, let's see, 2/3, 0, 0, would be this line here, and it was below it, so it would be over here. Okay. Then this second one was below it, and that would be here and here. So if we go for where the two intersect, it's just down there. Okay. Just to make sure, let's pick a point that's within that region. How about 0, -2? And let's verify that that is a solution to both. So let's go with green. And what did I say, 0, -2? Yeah, so 0, -2. Let's plug it in here and in there and see if it works in both cases. 3 times 0 plus -2 less than or equal to 2, -2 less than or equal to +2. That's true. Over here, 4 times 0 minus -2 greater than or equal to -2. 2 is greater than or equal to -2. That's true as well. Okay, so problem number 7, we're good to go. Let's clear that and go to problem number 8. And we're going to change our ink back to black. So we're going to start over. We've got 2x plus y greater than or equal to 4. So we'll find the related equation, 2x plus y equals 4. And we'll find a couple of ordered pairs. I'm going to go after the x and y-intercepts again. To find the x-intercept, y is 0, so you get 2x plus 0 equals 4. 2x equals 4. X equals 2. To find the y-intercept, you set x equal to 0. 2 times 0 plus y equals 4. Y equals 4. So we're going to plot the 2 points, 2, 0 and 0, 4. Double check here. Yep, 2, 0, 0, 4. Okay. This also includes equals in the original inequality, so I want a solid line. 0, 0 looks like a good test point. So let's take 0, 0 and plug it in to the original inequality. 2 times 0 plus 0 greater than or equal to 4. 0 greater than or equal to 4, that's false. So 0, 0 is not on the correct side. Consequently, it would be above. So we would do above the line. Okay. Now let's go back and do the red inequality. I'm going to look at the related equation, y equals 4x minus 8. And we'll find the x and y-intercepts here. If y is 0, 0 equals 4x minus 8. I'm going to add 8 to both sides. 8 equals 4x. Divide by 4. 2 equals x, or x equals 2. To find the y-intercept, set x equal to 0. Y equals 4 times 0 minus 8. So y equals -8. Now let's plot those 2 ordered pairs. 2, 0. And 0, negative, oops, 8. 2, 0, 0, -8. That's also a solid line because it also includes its y is less than or equal to. Okay. And again, I could use 0, 0 as a test point. So we'll put that into our original inequality. 0 less than or equal to 4 times 0 minus 8. 0 less than or equal to -8. That's not true. So that again is false. So let's see here. Which line is that? That is this line here. 0, 0 is not true. So it's going to be below. So over here and here. So below. Okay. So going back here, for this line, it was above. So that would be here and here. For this line, it was below. So that would be here and there. Right. So that's the one that is in both of them. Let's pick a point there and test it. How about 7, 0? So let's go to green. And let's put in 7, 0. Let's see. If we plug that in there, we get 2 times 7 plus 0 greater than or equal to 4. 14 is greater than or equal to 4. So that checks. Put it over here. 0 less than or equal to 4 times 7 minus 8. 0 is less than or equal to 28 minus 8. 0 is less than or equal to 20. That checks as well. Okay. 2 down and 3 more to go. So we're going to clear this and go to problem number 10. Change back to black ink there. So we're going to take this inequality and we will find its related equation, which would be 3x plus 2y minus 15 equals 0. And I'm going to find a couple of ordered pair solutions. How about the x and y-intercepts? To find the x-intercept, set y equal to 0. 3x plus 2 times 0 minus 15 equals 0. 3x minus 15 equals 0. Add 15 to both sides. 3x equals 15. Divide by 3. X equals 5. Find the y-intercept by setting x equal to 0. 3 times 0 plus 2y minus 15 equals 0. 2y minus 15 equals 0. Add 15 to both sides. 2y equals 15. Divide by 2. Y equals 15 halves. Okay, so we'll go over here. And we've got 5, 0. 0, 15 halves. 15 halves is 7.5. So I'm going to put it right there. Oh, it didn't like it. It went up to 8. So I got 5, 0, and 0, comma, 15 halves. Okay. And the inequality includes equals in the original. So it's a solid line. Let's use 0, 0 as a test point. So we'll plug that into here, and we get 3 times 0 plus 2 times 0 minus 15 greater than or equal to 0, negative 15 greater than or equal to 0. That's false. So 0, 0 is not correct. So it's going to be on this side. It's going to be above. So above. Okay. Now we'll come back and make this red and go over here. We're going to look at the related equation there. And again, I'm going to find x and y-intercepts. The only time I wouldn't find both x and y-intercepts is if they were in fact both the origin, because then I'd only have one point. So then I'd find a different point other than just an intercept. Okay, if y is 0, x equals negative 1 plus 0, so x equals negative 1. If x is 0, 0 equals negative 1 plus y, add 1 to both sides, and 1 equals y. I know I'm going kind of quickly to get these done, but you can slow them down and back them up or watch them upside down, whatever you want to do there. Negative 1, 0, 0, 1. Oops. That's not what I wanted. I wanted this one. Negative 1, 0, 0, 1. Ah, this one does not include equals. So it's going to be a dashed line. Okay. Again, I could use 0, 0 as a test point. So let's put that in here. 0 less than negative 1 plus 0, 0 less than negative 1. That's false. So for the dashed line, 0, 0 is not correct, so the fill would be above it. Okay, so if it's above for the dashed line, and it's above for the solid line, the intersection would be up here. Once again, let's pick a point and make sure. How about, let's see, 4, 9. 4, 9. That looks like it's in that solution region. Okay. So 4, 9. We'll put it in here. 3 times 4 plus 2 times 9 minus 15 greater than or equal to 0. 12 plus 18 minus 15 greater than or equal to 0. 12 plus 18 is 30 minus 15 would be 15. Whoops. What did I do now? How fun. Okay. Apparently it's going to do everything I say now. There, I think we fixed it. Okay. So I'm not even sure what I did to cause that, but I'm still learning. So 4, 9, what did we, oh, we're, okay. Sorry, I kind of got lost here. Oh, we were going to pick a test point, 4, 9, and we plugged it in to here. And I think I had 15 is greater than or equal to 0. So it's true. And then over here, 4, 9, 4 less than -1 plus 9, 4 less than 8. That's also true. So it checks. Okay, sorry about the confusion there. I'm not sure what I did, but anyway, let's clear that one and go to number 11. We'll look at the related equation, x plus y equals 0. We'll find the x-intercept by setting y equal to 0. So here's a case where this goes through the origin, so I'm going to have to use a different value than 0. How about 1? So if x is 1, 1 plus y equals 0. Subtract 1, y equals -1. So we've got, let's see here, 0, 0, and 1, -1. 0, 0, 1, -1. Okay. This does not include equals. So I want to make it a dashed line. Okay. Also, it goes through the origin, so I can't use the origin as a test point. How about, let's go with 4, 4. Okay. So 4, 4. We plug that in there, we get 4 plus 4 greater than 0, 8 greater than 0. That's true. And 4, 4 is above the line. Okay. So above. Alrighty. Now let's do the red inequality. We'll look at the related equation. I'm going to find a couple of ordered pairs here. If y is 0, I get 0 minus x equals -2. Negative x equals -2. Divide both sides by -1. X equals 2. If x is 0, y minus 0 equals -2. So y equals -2. Excuse me. Okay. So 2, 0, and 0, -2. This is also going to be a dashed line because it doesn't include equals 2. Okay. And let's see, can I use 4, 4? Yeah, I can use 4, 4 on this one. You don't have to use the same test point, but may as well. So we get 4 minus 4 less than -2, 0 less than -2. That is false. So the second line, which is here, 4, 4 is not a solution, so it's over here, so it's above. Excuse me, it's below. So for the black inequality here, it would be, let's see, here and here. It's above, okay. For the red inequality, it would be here and here. So the intersection would be there. Let's see, let's take, how about 10, 0 as our test point for the whole thing. So we'll put that in there. 10 plus 0 greater than 0, 10 greater than 0, check. We'll put it in here. 0 minus 10 less than -2, -10 less than -2, check. All right, we've got one more to go. Hang in there. So here we go with number 12. I'm just getting the hang of this thing here. Okay. So we're going to look at the related equation, y plus 2x equals 0. We'll set y equal to 0 and get 0 plus 2x equals 0. 2x equals 0, divide both sides by 2, x equals 0. Since it goes to the origin, I have to find something other than another intercept. How about if x is 1? We get y plus 2 times 1 equals 0. Y plus 2 equals 0. Subtract 2, y equals -2. So 0, 0, and 1, -2. 0, 0, 1, -2. Solid line because it includes the equal to in the original. Can't use the origin. Let's go back to 4, 4. I don't know, for some reason I just like that. 4, 4. 4, 4. That'll be our test point. Putting it in there, we get 4 plus 2 times 4 less than or equal to 0. 4 plus 8 less than or equal to 0. 12 less than or equal to 0. False. So 4, 4 doesn't work, meaning it's got to be over here, so it's below. Okay, because the 4, 4 didn't work, so it's on the other side. All right, now let's go to the red inequality. We'll look at the related equation, y equals 1/2 x plus 1. Since my coefficient of x is 1/2, if I use multiples of 2 for x, I should get nice y values. So let's go, how about 0 and 2? If x is 0, y equals 1/2 times 0 plus 1, or y equals 1. If x is 2, y equals 1/2 times 2 plus 1. 1/2 times 2 is 1. 1 plus 1 is 2. Okay. So let's see here. 0, 0, 1, and 2, 2. That line will also be solid because it includes it equal to. And let's see, I can use 4, 4. It's right up there. So we'll use 4, 4 as our test point. In our original inequality, 4 less than or equal to 2, or 1/2 times 4 plus 1. 4 less than or equal to 2 plus 1. 4 less than or equal to 3. That's false. So 4, 4 doesn't work here. So it's got to be over here, which would be below. Oops. Okay, so it's below this one and it's below that one. So this would be the intersection. Let's pick a test point there. How about -5, -5? Okay, that's in that region. So we'll put it in there. -5 plus 2 times -5 less than or equal to 0. -5 plus -10 less than or equal to 0. -15 less than or equal to 0. That one checks. Let's put it in over here. -5 less than or equal to 1/2 times -5 plus 1. -5 less than or equal to -5 halves plus 1. -5 less than or equal to, let's see, -5 halves plus 1 would be the same thing as 2 over 2. So -5 less than or equal to -3 halves. Think about it on a number line. Okay, you got 0, -1, -2, -3. -3 halves would be -1.5. -5 would be over here. So yeah, -5 is less than or equal to. So it checks. And there you have it. So I'm going to stop the recording. And